There I am. This video is going to be working on graphing trig functions that have shifts with them. This set of videos are the last ones for chapter 7, so congratulations, you're almost there. A quick review. Yesterday, we learned how a sine graph starts and ends on your midline, hits the midline in the middle as well, and it looks like a roller coaster. And yesterday we learned how the cosine graph has more of a U shape where it starts and ends up on the ceiling. In the middle, it's down at the floor of the basement, and it hits the midline twice in the averages of there. So you get this nice U-shaped curve. All right, what's going to happen today with shifts is that it's going to be what you've done with parabolas and absolute values and square roots, is that maybe the ceiling and the floor, maybe it's going to stretch. We practiced that a little bit yesterday, stretching bigger or smaller. We talked yesterday about the cycle being wide, like an accordion. Maybe it stretches out or accordion's in really small. What's going to happen today is maybe the midline moves and the whole thing shifts up 3 or down 7. Or maybe yesterday we always started on the y-axis, is where we started our sine and cosine graph. So that was always the left wall. Today what's going to happen is maybe the walls are going to shift to the right and to the left. And you have to learn how to handle that. And I actually think you're equipped and ready to do very, very well at this because of all the work you've done so far in this class. All right, so as a reminder, yesterday we learned y equals a sine of bx, or y equals a cosine of bx, and we learned that a is the amplitude. This marker is done. Let's see if I have another purple one. I don't think I do. I'll have to switch to blue. A was amplitude, and B stood for frequency. Now if you look, we're adding a little more. We still got the A, we still have a B, but in with the X, we're putting a minus H, and then at the end, we're putting a plus K. I'm hoping that it has meaning for you, that the H will give us a horizontal shift. That'll move our walls to the left and to the right. And the K will give a vertical shift, moving our ceiling and floor up and down. Remember, amplitude was like the stretch, and the frequency was like how many cycles you get into 2 pi. So if this is 2 pi long, the frequency of that would be 2, because you see 2 full sine curves in 2 pi. So it would be worth writing these down. And they look kind of scary, except now that they don't, because you are very used to the H and the K. And yesterday you got used to the A and the B. So now we know how to handle these things. All right, so very quickly write these down. And it should just be real easy. If you have y equals sine of x, what does that plus 5 do to it? It's going to shift the whole thing up 5. So what'll happen is your midline, instead of being on the x-axis, is going to be a horizontal line at y equals 5. The whole thing is going to shift up 5. All right, this next one is more complicated. Y equals a negative cosine of x plus pi. Well, the thing in with the x, hopefully that reminds you that we are going to shift. A plus pi makes you think to the right, but remember with the horizontal shift, you do the opposite. So the plus pi means you're going to shift to the left pi, or like 3.14 units. And then if anyone can remember, what happens when that A value is negative? Right here, I see an A value, an amplitude of -1. That simply means there's a reflection. But the ceiling and the floor will still be 1 above and 1 below the midline. So if I sketch this, my original cosine graph would look like that. if it's going to shift to the left pi, that means my left wall is going to shift over from here to here. And then a reflection, instead of starting at the ceiling, it's going to start and end at the floor. So it'll look something like that, just flipped over. All right, let's look at our next one. Y equals cosine times 3x minus pi minus 4. A lot's going on there. I see a shift down 4. I see it's shifting to the right pi. So that's the 4 and the pi. What else is going on? An amplitude. That would be out in front here. Since there's nothing there, there's an amplitude of 1. That 3, that's the B. You have a frequency of 3. So that means between 0 and 2 pi, oops, you can't see that anymore. That means between 0 and 2 pi, we're going to see 3 cosine graphs. So you'd see 1, 2, 3. You can kind of see the walls here, 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 and here. So not a great sketch, but it gives you the idea. And then you should get the period, which is 2 pi divided by the frequency. That makes sense. It's 2/3 pi. Because if this is 2/3 pi, this is 2/3 pi, and this is 2/3 pi. Well, 2/3 plus 2/3 plus 2/3 adds up to 6/3 pi, which reduces to 2 pi, which is what we needed. So I feel good about the period being 2 pi over 3. This one is definitely worth writing down because a lot of kids say that the A value, the amplitude, is 6, and it's not. The amplitude sits right here next to the sign. It looks like the amplitude is actually a -1. I personally would rewrite this with the +6 tacked on the end over there, because then I think it's easier to see that this whole thing shifts up 6. It's going to go to the right pi over 4. The amplitude is -1, which means there's going to be a reflection. It's going to flip upside down. I'll kind of give you a sketch of that part in a minute. And then what are we missing? This 2. We have a frequency of 2. And so that means that the period is 2 pi divided by the frequency. So I have a period of pi. So this sketch is going to be kind of rough. There's a lot going on in this one. I'll see if I can cover everything. The whole thing is shifted up 6. So there's your midline. Start with the midline, and then with an amplitude of -1, that just means you go up 1 for the roof and down 1 for the basement. Kind of move that right there. All right. And then if we're moving to the right, pi over 4, this would be like the left wall. And then if it only has a period of pi, that means the right wall will be at 5 pi over 4. Because that's 1 pi over 4. All right, this is the ceiling. There's the basement, so it's going to fit into there. And if it has a frequency of 2, that tells me in 2 pi, we will make 2 cycles through. So here represents 1 cycle. It is a sine graph, so it's a roller coaster, but it's a reflection. So the regular roller coaster looks like this, starting and ending on the midline and in the midline, but instead of going up first, we'll have to go down. So that would be 1 cycle, and then we will have another cycle again, because in 2 pi, it will go through twice. But we will practice that a lot. That was meant to be a sketch. I got a little more thorough than I cared to here. This one, I think I'm going to actually go to decimal. So we're just going to compare y equals cosine of x plus 2. And then this one, I would personally rewrite as cosine of x minus 3. Amplitude of 1, shift down of 3. So let's see what happens here. I've got a lot of stuff plugged in, but I'm just going to show this one, y equals cosine of x. So I feel kind of good about that. Like you think about the left wall being at x equals 0, and then the right wall is at 2 pi, which is 6.28. That makes sense to me. 2 pi is right around 6.28. I feel good about that. So what's going to happen when I do the y equals cosine of x plus 2, that whole graph should just shift up 2. Yeah, feel good about that. So this point that was at 0, 1 is now at 0, 3. 6.28, 1 is at 6.28, 3. Right here, pi is at pi negative 1 will be at pi positive 1. So the whole thing just moved up 2. So this one, this negative 3 plus cosine of x, that means the whole thing just moves down 3. So there it is in green. And then I wrote it this way. That makes a little more sense to me. I do worry that students here will think the amplitude is 3. The amplitude sits multiplying the cosine, not adding or subtracting. So actually what I have here in green and in purple are the same. See, the green and the purple represent the same amount. So that's just a nice little illustration of what the adding or subtracting does to the graphs. It just moves them up or down. All right, let's clear that out a little bit. I still have the wall on my left, the wall on the right. Let's see what happens here when I do y equals sine of x. That should look more like the roller coaster. So I put the roller coaster in. I feel great about that. I have the beginning and the end on the midline, which is the x-axis, so 0 and 2 pi. So this is a period of 1. No, I'm sorry, a period of 2 pi, because that's how long it takes, or the distance to get one full cycle. It has a frequency of 1, because there's one cycle in 2 pi. Halfway through, it hits the midline again, and then it hits the ceiling at pi over 2. And the floor at 3 pi over 2, what we learned about yesterday. I just really want to illustrate now what happens. This one tends to be a little bit harder. Down here, this y equals sine of x minus pi over 2. The whole thing is going to shift pi over 2 to the right. So there you go. In green, all of a sudden, this point at the origin now is right there. So it's kind of like it's moved pi over 2 to the right. That's where the new wall happened. Let's see if I can actually do an equation there. I didn't try this out yet. Yep, there you go. So if I make that vertical line x equals pi over 2, that is the new wall on the left. So that's where that cosine starts. And then it's not going to, instead of ending at 2 pi, it's going to end over a little bit further at 5 pi over 2. So you can kind of see how it's shifted. Pi over 2 to the right. If I change this to a plus pi over 2, it would shift pi over 2 to the left. So this point, the starting point of 0, 0, is now at negative pi over 2, 0. It's moved pi over 2 to the left. All right, and I think I'm going to end the video here, and please watch the next one because I'm going to do a bunch of examples of graphing different ones like this, which is what you will have to do on your homework and on a test. So stay tuned. Please watch the next video. Thank you.